Good day, everyone. My name is Jessica Porras, and I'm the Senior Manager for Education and Outreach at CAQH Core. It is my pleasure to welcome you today to our fourth webinar in the series on electronic healthcare attachments. Today's webinar will focus on the Clinical Document Architecture, or CDA Body. Before we begin, I would like to mention a few logistical items. You will be able to download a copy of today's presentation from the CAQH.org website in the next 24 hours. To do so, navigate to the Core pull-down menu at the top of the CAQH.org welcome screen and select the Core Education Events page. A link to the PDF version of the presentation, as well as the recording, will be found under the listing for today's webinar. And just to reiterate that the slides and the recording will be available tomorrow. We will save time at the end of today's program to respond to audience questions. You're encouraged to submit your questions at any time during the webinar by typing them into the questions panel on your dashboard. We do ask that when you submit your question, please identify the type of organization you're with so we can give you a more applicable response. Next slide. Our session today will start with an overview of CAQH Core's work on attachments before we move on to a detailed presentation on clinical document metadata for attachments, focusing on the CDA body. I want to remind you that this is a 90-minute presentation. Next slide. This slide goes through the purpose and learning objectives for this webinar. You can read it at your leisure. Next slide. Let's get started with an overview of the CAQH Core Attachments work from CAQH Core Director, Robert Bowman. Bob?
Great, thanks, Jessica. And as you can see on our first slide, and something that we want to make sure that everyone's well aware of, that CAQH Core is a mission and vision-driven organization that uses a very specific integrated model that we work with through the industry. And that model, and again, with our vision and mission, is to develop a set of operating rules that can be used by the industry through the use of very specific standards and operating rules together to ensure that we can actually facilitate interoperability between trading partners. We have been designated by HHS as the national author for operating rules, the authoring entity for operating rules. And we do have our own board that helps us monitor our progress, helps us focus on very specific topics. And you'll see through today that one of those topics for us that's going to be very important for 2018 is attachments. So again, going through our integrated model, we will develop a set of operating rules, roll those out with a certification program, build awareness and educate the industry, provide assistance, promote adoption, track and maintain any sort of operating rules that we develop. But what are operating rules? On the next slide, you'll see that the operating rules that we develop are specific to not just standards in healthcare, but to any standard that will help improve the operation and implementation of standards within our industry. So we don't look at just healthcare standards, but also industry neutral standards as well. Again, we don't repeat or reiterate anything that's within the standard. That's not the goal of operating rules. The operating rules are really to ensure that we can develop an interoperability between systems and applications, not just on the administrative side, but also on the clinical side. We look at operating rules in really two different categories. One is a set of infrastructural rules that help build and apply across all transactions, that really help build a system or a network of interoperability around very specific parts of data, the content rules, the data content rules that we also have. So infrastructure are things like connectivity and security of response time, system availability, roles and responsibilities of trading partners, acknowledgments of handing off transactions from one entity to the other. And the content rules are specific to the type of data that's within the transaction or within the standard, and ensuring that those kind of switches are flipped on so the providers and health plans have the data that they need to make a sound business decision. Looking more specifically at attachments in that broad category, as soon we're going to go into a lot of detail, but on the next slide you'll see that from the 2016 CAQH Index report, the report indicated that only 6% of healthcare claims attachments are submitted electronically today. The rest, those other 94%, all come through fax or through mail. 100% of health plans did report that they receive manually submitted claims attachments. So every health plan has a process in place to receive paper-based and fax-based claims attachments today. So that means that it's a very labor-intensive and very costly process for both providers, intermediaries, and health plans today. And with even some of the low numbers that we have within the index, entities can save about 14 minutes and over $5.60 per transaction, per claim attachment, if they were to migrate to a fully automated electronic process. There's only been limited use of the X12 standard through those 6% of health claims attachments that come in, and no one had reported use of the HL7 standard. Again, as we'll see probably from the numbers for the new index report that will be coming out later for 2017, there's probably some change to that. And we'll have Rick Gummer here, we'll hear from him in just a moment, about some of the progress that's been made as well. What's important to note and what's going to be impactful for everyone on the call today for 2018, if we look at the next slide, is that in December of last year, in 2017, just last month, HHS Unified Agenda was published, and it does call for an NPRM in August of 2018 that is going to include a proposed rule that would adopt standards and operating rules for attachments. So again, very important as the industry gears up towards an official designation through HHS on potential standards and a timeline for those standards to be adopted by the industry. So again, making sure that everyone's well aware that we're looking very closely and we're monitoring the industry as we move forward. Part of that is also our scope of work that we have. And on the next slide, you'll see that not only has CAQH Core been part of our education series, and this is the fourth one that we've had over the course of the last, I think, 7 or 8 months now, of which we will continue to do through 2018. That industry education is going to be key to how the industry adopts and moves forward with operating rules and standards for attachments. We're also using the education series as part of our environmental scan. You'll see through some of our polling questions, we're trying to get some information from the industry, from the attendees on this call, on what attachments mean, some of the problems, some of the challenges, and how to participate in some of the efforts that we have. So again, part of that environmental scan includes where the industry is at today, what trends are moving forward month to month in some cases, different types of pilots that are going on, different types of implementation projects that are going on. We are currently interviewing core participants. We are looking at our board members, we're looking at any core participant, we're looking at the index. We are having those phone call conversations and interviews with those folks on how they're implementing electronic standards today for attachments, how their manual processes work, what are the workflows that they've established, what seems to be working better for some providers versus other providers. So those are the types of conversations that we're having today. All of that will funnel into an advisory group and a subgroup process that we have established for all of our projects, including the attachments project. So the advisory group will be chaired, and the environmental scan findings will help us develop a list of high priority opportunity areas for recommendations for an attachment subgroup to consider for operating rules. So I know I just spoke a lot about what the advisory group is going to do, and then the subgroup's going to launch, and they're going to actually write operating rules around attachments. But all of that is going to be important for those that are participating in core, and for any entity that's in the industry that wants to be part of that process. We'll have an opportunity to share with us exactly who you are and how we can work together. A little more detail on the environmental scan is found on the next slide. Again, we are looking to help inform ourselves, core, on the different opportunity areas that are going to be key in driving specific components of operating rules. Part of that is going to be the drivers of frequency of the various attachment types, from a claim to prior authorization to audits to referrals to post-adjudication requirements for attachments. What are the volumes? What are the current attachment types and methods used for submission? Are there common requirements today that providers are adhering to, that health plans are promulgating to the industry? What does that look like? And also, what kind of products are in the marketplace? Are the PMS systems part of this process? Is it a separate system? Is it a provider portal that a health plan has in place that allows for an upload? Again, a very manual process, but it might be what's in place today for providers. We need to know exactly what that volume is, what those requirements are, what the turnaround times are, again, those roles and responsibilities are going to be really important. We have developed an interview guide. We're also offering telephone interviews as well as site visits for entities, again, core participants or not. Anyone that's interested in being part of that process, we'd like to know how you do it today. So again, those phone interviews are going to be really important. They are structured interviews. We also have half-day on-site visits that we'll do and walk through your business flows for how you submit these different types of documentation for different purposes to different entities around the country, making sure that we understand those best practices. So it is a call of action to anyone on the phone today. If you're interested in partnering with us on a phone interview or a site visit, if you need to have time to encourage your colleagues in your systems and applications of what those numbers are, what the volumes are, how you're doing transactions and attachments today, this can be really important for us. So with that, I'll hand the call back over to Jessica for our first polling question that's right along these lines. Jessica?
Thank you, Bob. And thank you for setting up the first polling question, which I think we can go ahead and launch. So given what you just heard from Bob regarding the attachments environmental scan, if you're interested in providing input to that environmental scan, which will then inform eventual development of operating rules, please click yes. And if you're not sure, you need more information, there's an option there for you. And if you are interested in the operating rule development process, then you can always contact us and become a CAQH core participant. So let's give this a few more seconds. And this is information that we are going to use for follow-up, so we won't be sharing the results. So let's go ahead and close the poll. Thank you very much. And we'll move on with our next presentation. We will continue our program with our guest speaker, Rick Geimer, who is the Chief Innovation Officer at Lantana Consulting Group, and his presentation will focus on the technical aspects of the CDA body. Thank you for being with us today, Rick.
Thank you, Jessica and Bob. So thank you all for joining. As Jessica said, we're going to be discussing how to create clinical content for attachments using the CDA body. So why don't we move on to the next slide that lays out the agenda. So after the brief introduction, where we'll talk about scope and the audience and such, we're going to go into a brief recap on the standards that are used for attachments. Previous webinars went into details on all the standards that are used. This one, we'll just do a brief recap and then move on to the details of the CDA body. In there, we'll discuss the various options for creating a CDA body, discuss how narrative content and coded data are represented. After that, we'll discuss how to render CDA documents, how you display them on screen or convert them to other formats like HTML. Move on to validating CDA documents, ensuring that the documents that you create are correct according to the standards, and also the ones that you received, making sure that they're actually valid before you process them. Finally, we'll wrap up with some live demonstrations so you can actually see how all this stuff works together, and then some questions and answers. So next slide. In fact, I think you can skip 2 slides here. There we go. So the audience for this presentation is meant to be largely a technical audience. So technical implementers and provider, payer, and clearinghouse settings, such as those that are listed down below. If you're not a technical person, don't worry, you can still get value out of this. Just be aware that there is a lot of technical material in this presentation. You'll be seeing raw XML, and I'll be talking about things like style sheets and validating schemas and such. So just kind of bear with all that. Okay, next slide. Right. So the purpose and scope of this presentation is to give an overview of the clinical document architecture or CDA specification. We're going to talk about, again, ways of representing clinical content in CDA. We're going to give an overview of CDA implementation guides and discuss what they are and how they're used. And then again, guidance for displaying and validating CDA documents as we discussed on the previous agenda slide. Okay, so next. And we can go ahead and go forward one more from our attachments recap. So this diagram here shows the basic orchestration for a solicited claims attachment scenario. In this case, a provider is going to submit a claim using an X12-837 transaction. The payer would receive that claim, review it, and decide, for instance, that they need to request some more information before they can pay it. So in this case, the payer would be sending an X12-277 RFI back to the provider, detailing what kind of clinical information they're looking for. That will typically be in the form of a code, a document type code saying what type of document they're looking to receive back. The provider would then get that document that they're looking for, create an X12-275 transaction, and embed the CDA document in there and send it back to the payer. And you note in the center there's these sort of gray circles with clearinghouse mentioned. That's just to note that this could work optionally with clearinghouse as an intermediary at any of these steps. It's not required, but it is an option and one that a lot of implementers choose to use. Now, if we were to use an unsolicited scenario, this would look very similar. It's just that whole middle part of the 277 RFI going back would be eliminated there, and you'd just be sending an X12-837 claim and the X12-275 with the CDA payload at the same time from the provider to the payer. Next slide. So how this whole CDA and X12 work together, you can think of the X12-275 transaction as an envelope. And on the front of that envelope, you might have, in the regular paper world here, you might have the sender's address, the receiver's address, all that type of information. In this case, the metadata in the X12 is going to contain information that ties the attachment to the patient, to the claim, and if it's a solicited attachment, to the actual solicited, the attachment request, that 277 RFI. The CDA document you can think of as what you put inside that envelope. That's the payload containing the detailed demographics, clinical content, who, the author and attester information, who authored and who signed this document. And then, so that way basically the CDA becomes the payload in the X12-275 envelope. To put that in there, you're actually going to base 64 encode the CDA document and store it in the binary data segment, or BDS field in the X12. All right, next slide. So a little bit of background on CDA. CDA stands for Clinical Document Architecture. It is a specification for describing how to exchange clinical documents. It defines the document structure and semantics. For instance, that it uses XML as its primary syntax and allows for coded information such as LOINC, SNOMED, ICD-10 codes to be present. All that's defined in the Clinical Document Architecture specification. It is both an ANSI and an ISO standard, so it is not just US realm, it is also international in scope. Clinical documents, as they stand, are the authenticated part of the clinical record. They have a human readability requirement, so every clinical document, every CDA document can be brought up and displayed to a user. In other words, they're not just machine processable. You can always render them and just read them if you need to. They can also contain coded data as an option, as use cases are, define them. It is important to understand that CDA represents an architecture. The CDA specification itself is very generic and can describe any type of clinical document anywhere in the world. So we use what are called implementation guides to constrain CDA for specific use cases. And I'll talk more about that in the next few slides. So next slide. So first of all, the CDA documents consist of two main parts. The first part is the CDA header. This identifies the metadata that is important for setting the sort of scope and context of the document. It'll identify who the patient is, who the author is, what kind of document is it a history and physical, a discharge summary. It's basically the information that is sufficient for document management and such, so you can look up documents, retrieve them quickly and easily by patient, by type, by date, all that type of stuff. The CDA body is the part that actually contains the attested clinical content. This will be the human readable narrative portion, as well as any coded data that will be all present in the CDA body. Now, the previous webinar in this series, the third webinar, focused on the CDA header. So we won't dive into details on that today, but if folks are interested, I believe that's still available up on the CAQH website. So I would point you to that previous presentation. This webinar will focus on the CDA body. Next slide. So I mentioned implementation guides and also mentioned that the CDA specification is generic. So it is very flexible, very adaptable, but out of the box doesn't necessarily satisfy any given use case or satisfy any given requirement. That's really what implementation guides are for. Implementation guides typically will define a use case for a particular kind of document and then describe what content is expected in it, such as what sections are mandatory or optional, what level of coded data is required for this particular use case. Some examples here, again, I mentioned a history and physical document. That one might lay out that there's several required sections present and a variety of optional ones. Also, meaningful use summary documents are another use case, which will have a large amount of required coding data for the most part. So again, implementation guides, you can think of them as a layer on top of the generic CDA specification that gives you additional guidance and constraints. Next slide. So for attachments in the US, we developed an HL7 attachment implementation guide through the Health Level 7 organization. And this guide lays out the rules for what represents a legal attachment. And for the most part, they're pretty simple. What we decided to do was to allow any CDA document that uses what's called the US ROM header to be sent as an attachment in the US. The US ROM header I described in detail on the previous webinar where we talked about the header. It's basically what we call a template, which I'll just define in a couple slides here, that lays out the required metadata for the header. For instance, that you must have a patient present. If you have a provider, you should list their National Patient Provider Identifier, or NPI, as one of their IDs. So there's a lot of basically rules in there in the US ROM header that make it useful for exchanging documents consistently in the US. So what we said, again, was any implementation guide that uses the US ROM header is legal for an attachment. The US ROM header was defined in the CCDA, or Consolidated CDA specification. CCDA is an implementation guide that's been through several versions. The most current one is release 2.1. But there are other implementation guides, such as those listed here, that reference the US ROM header from CCDA. And so once they do that, they also become legal attachment guides. And all of these constrain the base CDA standard, as this diagram shows it. The HL7 Clinical Document Architecture, or CDA Release 2, is at the very bottom. And this just shows that all the implementation guides above are legal constraints on the CDA specification, and therefore are themselves, do themselves define CDA documents. Next slide. So there's a list of implementation guides up on the screen here that define the implementation guides, or IGs as we call them, that are legal for attachments. Again, I mentioned on the previous slide all the ones that use the US ROM header are legal. This is just a short list of the ones currently that support that. Consolidated CDA, where the US ROM header was defined. There's a new periodontal attachment implementation guide out, the clinical oncology treatment and summary plan, and so on and so forth. It is important to note that this list is extensible. For example, there's a new project proposed for creating an implementation guide for orthodontics. That one will use the US ROM header, and therefore once it's finished and published, it will become a legal implementation guide for defining attachments as well. And there are plenty of others that are proposed or in the works as well. So this list will grow over time. Next slide. Okay, so I mentioned CCDA, or Consolidated CDA. CCDA is a implementation guide. In other words, it's a constraint on CDA for the US realm for defining US documents. It defines several document types. I would say close to a dozen, I believe, and as well as the legal sections that compose those documents and any coded data that might be present. So the body of CDA documents that conform to CCDA can't contain required meaningful use data, such as problems, allergies, meds, and so on and so forth. And that can be either represented using narrative or coded data, or a combination of both, which is the most common, I should say. The narrative is always required, actually. Some document types have optional coding, others have required coding. Most of the summary documents that you see exported from EHRs, for instance, are required to contain a high level of coded information, such as problems represented in SNOMED or ICD-10 and such. But again, that's not true of all document types, and I'll describe that in a little more detail later when I talk about the various body types. Next slide. Okay, so here's a list of the document types that are available in Consolidated CDA Release 2.1. Probably the most common one that folks have experienced or seen exchanged so far are the Continuity of Care document, or CCD. This is one of the most common summary documents that are exported out of EHRs. The other document types, such as discharge summary or care plan, are also seeing more and more uptake over time. One of the ones that we're going to discuss in a bit of detail later is actually one that was excluded from meaningful use incentive programs, and that's the unstructured document. This is one where you could, for instance, send a document with a same CDA US ROM header as everyone else, but it would contain, for instance, a PDF instead of highly structured coded data. So this one I want to highlight because we think that's going to be actually a very common use case for attachments, even though it wasn't very common under meaningful use. Okay, next slide. So I mentioned templates briefly before, and I'm going to go into a bit more detail on them now. Templates are a layer of constraints that you apply to the generic CDA model to tailor it for a specific use case or specific implementation. I tend to think of things in terms of cooking analogy, since I'm a big foodie myself, and I like to think of a template as almost a recipe for creating CDA documents for a particular purpose. So the CDA or CCDA implementation guide itself contains a library of templates, so you can think of that implementation guide much like a cookbook that gives you the recipe for creating various document types and various snippets of sections, narrative, coded data, and such. Next slide. So to further that cookbook analogy, CDA without templates, I mentioned that CDA is an international standard. It can just define any type of document type. It's very generic. So you can think of CDA as a kitchen just full of raw ingredients, but no menus, recipes, cookbooks, or anything else present. This is the kind of kitchen that my grandmother had. She would walk into that kitchen, she'd know where everything was. She'd start throwing ingredients in a pot, and she'd come up with this great meal. But really, no one knew what we were going to get. Most of the time, you don't even know quite what went into it. And that kind of kitchen is great if you know everything that's present there, if you know what you want to cook, and you're good at improvising. But it's hard to use if you don't have experience, cooking in that style. Really, only the cook understands what's going into the meal and before it arrives at the table. Now flip that with CDA with templates. In this case, you're more along the lines of what you would see in a restaurant. So you might have the same ingredients in the kitchen, but there's a set of menus that the diners can order from, and those menus correspond to recipes back in the kitchen that the cooks follow. And when you have this approach, there's a lot more consistency. Both the diners and the cook know exactly what to expect, and it's easier for the novice to actually create CDA documents or meals in the analogy case, because you've got recipes to follow. So you don't necessarily have to sort of wing it and go by taste on how things are going. You follow the recipe, and you're pretty much guaranteed to get the thing cooked to order. Again, same with CDA templates. If you follow the instructions or the conformance statements that are in the templates, they'll guide you to creating a valid CDA document that follows all the rules that we use in the US, for instance, under Consolidated CDA. All right, next slide. Okay, so wrapping up that analogy, this is an example of a CDA observation in this case. What I'm showing is how you can sort of treat templates. Templates in CDA will say, for instance, you must have an observation element that contains a code. That code must contain a code from SNOMED describing a vital sign. It must have a date present, and it must have a measured value. So the stuff here that's highlighted in blue represents the variable data that an implementer would need to populate with their own live data, with their own data from a specific patient encounter, for instance. So when you take this, everything else that's in black here, you can think of it just boilerplate text that the implementer can just put into their system and then populate those blue values. If we go over to the left-hand column, or to the right-hand column, here we've got a fully populated instance. In this case, we've populated the code with the SNOMED code for body height. We've populated the date with the date of, in this case, November 14, 2012. And then the value at the end is 177 centimeters. So this, again, is a vital sign observation. It basically says the person's height was 177 centimeters on November 14, 2012. Next slide. Okay, so I mentioned conformance statements briefly. I'm going to define what they are now. It's a constraint that's defined in a template and allows an implementer to follow that constraint and thus conform to the template. Conformance statements are written in prose. I'll show an example on the next slide, but they basically constrain the base CDA standard. One important thing to note is that conformance statements can tighten constraints. You cannot loosen them. So, for instance, if something is optional in the base CDA standard, it is legal for a constraint to make it required in an implementation guide or in another template. However, you can't go the other way. If something is required in the base CDA standard, you can't go back and suddenly make it optional, because if you did, you would no longer actually be a compliant CDA document. So basically, you can tighten things up, you can make them more specific, you can make optional things required, but you can't take something and make the rule that it's no longer a CDA. Now, up on screen, there are some indicators here, what we call cardinality indicators, such as 0 ... star, 1 ... 1. These represent minimum and maximum values. So these are very common things that appear in conformance statements and in the CDA spec itself. It basically, for instance, you might have a constraint that says, you shall contain 1 ... 1 code. And what that means is that, in this particular field, you can have a minimum of 1 code and a maximum of 1 code. In other words, exactly 1. And that's something that happens quite common. For instance, if maybe the code was optional in the base CDA spec and you want to make it required in your implementation guide. Implementation guides can also set vocabulary, so they can constrain codes to a single code, for instance. You can constrain it to a value set or a list of codes, or you can constrain them to one or more coding systems, such as long and SNOMED and all that. Next slide. So here are some examples of conformance statements. So these are real ones pulled out of real implementation guides, Consolidated CDA in this case. So the first bullet basically just says that whatever template this is in, it shall contain exactly 1 code. It's basically the example I spoke to on the previous slide. It means that, again, a code is required in this area. The second one does a vocabulary binding. So this one says that this code should contain a 0 or 1 code attributes. So that's basically a SNOMED code in this case for a cognitive function finding. And by using the keyword should, this means that if you don't happen to use that particular code, it would generate a warning when you do validation. The previous bullet above has the word shall in it. So anything that is a shall constraint, if you were to validate this, it would actually generate an error if you were missing that code. So again, shall constraints correspond to errors if you fail to conform to them. should constraints correspond to warnings if you fail to conform with them. Okay, next slide. So how do you indicate in your documents that you're actually trying to conform to a template? In CDA, you do this by what are called template IDs. So you can place template IDs in your CDA document. By doing that, you can think of it as making a promise that you're actually following the rules of that template. So in this example, we've got two template IDs that we're showing, one at the document level and another at the section level. And we do this because I mentioned that Consolidated CDA, for instance, is a library of templates. They are templates for the various sections that can be used in there, and they can be reused among many document types. So we basically define the template for instance, a vital signs section once, and then we reuse it among various document types. And then when you create an actual document instance that uses those templates, you would put these template IDs in there to assert that you're conforming to it. And again, you can think of those template IDs basically as a promise. When you put them in your document, validators can pick up on that and then actually check to see if you constructed your document correctly. So that's valuable both for document creators, because you can check that you did your work correctly, and for document recipients, so you can make sure that somebody sending you documents is actually sending you a legal, syntactically correct file. Okay, next slide. All right, and you can advance it one more. We're going to go into details on the CDA body now that we've gotten through implementation guides and templates. So in CDA, there are three types of bodies that we're going to be discussing. First is the non-XML body. I mentioned this previously when I discussed unstructured document type from Consolidated CDA. This kind of body is used when you've got existing content, such as a PDF file or Microsoft Word. Maybe you've got a paper document that you've scanned, or you've got a system that just, that's all it can export as a PDF. In this case, you can still create the CDA US ROM header, just like you would for any CDA document for attachments. But then the body is just very simply, you're just going to include a PDF file or a Word document. That means it's still human readable. You can always bring it up and display any of those formats, but it's not going to have the same kind of coding that others might have. The second one is the XML body. This is what's currently being exported by EHRs under the meaningful use rules. CDA documents conforming to implementation guides such as Consolidated CDA will export these kinds of bodies typically, and they may include large amounts of coded data. The third one on here is it's a proposed body type that we're calling the simple XML body, also known as XDoc. This uses native CDA XML for representing the body, but all the requirements for coded data are removed. So basically, there's no requirement to export coded data with a simple XML body, but it doesn't prohibit it either. So this allows folks who want to implement CDA but maybe don't have the budget to do a lot of terminology mapping and coding to still get started, with your narrative or human readable documents, and then add coded data as the ROI is apparent. So it is important to note again, all these body types are human readable. They can be attested to by clinicians, and we'll show examples of how this happens later in the presentation. Next slide. So pros and cons of each of the various body types. For the non-XML body, key advantages, actually the first bullet is an advantage of all the body types, and that is consistent coded metadata. All of these use the US ROM header, and so therefore they all benefit from that. I didn't list it on all of them though. But the non-XML body, I would say its key unique advantage is the ability to repurpose existing content, like scanned paper documents, MS Word files, HTML, and such. That also means that they're very inexpensive to produce. You don't have to make a big investment to produce a non-XML body document because you just, for the most part, reuse what you have already. And in my opinion, non-XML body is the quickest path to get from paper or any legacy systems to electronic attachments. The cons here, the disadvantages, is again, the unstructured body document type was specifically excluded from the meaningful use incentive program. So if you're trying to comply with meaningful use, it's not going to be an option for you, at least in meaningful use's current incarnation. The other disadvantage is you are dealing with multiple formats. You've got not only the CDA XML that is wrapping the content, the CDA header and such, but you've also got to deal with a PDF or a Microsoft Word or HTML document embedded within it. So that can be a little bit problematic when you're rendering them, but not for the most part, not too much. The structured body, or the XML body, in this case, you've got all content in a single format. That's CDA XML. So it's you're not switching MIME types or anything partway through. There is coded data in most of these structured bodies that are at least the ones being shared today. That are, again, defined in industry standard IGs like Consolidated CDA. And that coded data can be used to drive decision support, auto adjudication, and such. The biggest con, I would say, is that these kinds of documents can be expensive and time-consuming to produce, and actually to process as well. And to get any benefit out of that, it really requires complementary rules. So you need to have a decision support engine or an auto adjudication system on the receiving end that can process that coded data. And without that, in essence, your investment in all that coding was, for the most part, almost wasted. You could say. Simple XML body is, again, this third proposed type. It has that same advantage as before, where all the content is a single format, CDA XML, but you only need to add coded data based on your ROI analysis. This means that it's also inexpensive to produce, much like the non-XML body, and contains text that could later be, for instance, processed using natural language processing, NLP as it's known, to pull out information that could potentially be processed. And again, it is all human readable there. Again, some of the downsides are meaningful use certification. The rules there do require a lot of coded data, so it would not, again, meet certification requirements for certified EHR under current rules. There are no required codes in the body. I list that as a disadvantage only if your system depends on coded data. If you're a receiving system that needs a lot of coded data, you won't typically find at least the extent that you would in a simple XML body that you would, for instance, with a structured body. Also, the document type codes are somewhat loosely constrained. So the proposed implementation guide for a simple XML body, or XDoc, just says you need to use one of the document type codes from LOINC, whereas the CCDA implementation guides give you value sets for each of the document types, or in many cases single codes. So based on the implementation guide exactly what you're going to pick. With a simple XML body, you might have to go to LOINC and look up, learn how to look up LOINC codes on your own. Okay, next slide. So let's go into some detail and examples on the non-XML body. The use cases for this are when you've got existing documents such as MS Word or HTML that are in electronic format, or if you've got paper documents that you need to scan. You've got a large filing cabinet full of manila folders, you need to turn those into attachments and send them electronically. Also, if you've got systems that maybe can only export PDF and such, or if you need to create a document type that does not have a CDA implementation guide yet. When I discussed CCDA, we listed about a dozen different document types that are available, but obviously in healthcare, there's more than a dozen document types that you can exchange, especially when you broaden that beyond clinical documents into administrative documents as well. So that list is, thousands that you could potentially have. So in short, we do expect for the attachments use case that non-XML body CDA documents are going to be quite common, because often when attachments are requested, they are requests for things like administrative documents or perhaps, again, document types that have not been fully coded for EHR exchange. Next slide. Right. When you're creating a non-XML body, you do have two options for how you can include files such as PDFs and such. The first method, which is currently the preferred method, is to embed them via base64 encoding. This consolidates all the content in a single file, but it does require that you decode the content before you can really use it or display it. So for instance, if you have a CDA document with a non-XML body and a base64 encoded PDF inside of it, you won't be able to render that PDF directly. You'll have to unencode it and then display it. So there's a little extra step there on the receiving end to extract that file. There is another mechanism that is allowed in CDA, and that is to reference an external file by a Uniform Resource Identifier, or URI. Typically, this ends up being just a file name that would be in the same of the PDF that would be in the same folder as the CDA XML with a non-XML body. The advantage of this is it can be directly rendered using standard CDA Style Sheets. The content is already split up in multiple files, so there's no re-encoding you need to do. And it is possible, there have been folks that have been concerned about security, that someone could just swap out that PDF file and replace it with something else. But there is the ability to include a hash in the CDA document to ensure that the file that it points to is actually the intended file. But I do want to note that the HL7 Attachments Implementation Guide requires all parties to support base64 encoding, and really only allows for using the reference mechanism when there's prior arrangement between trading partners. So basically, you couldn't send CDA documents with a referenced PDF file to someone in the blind. You'd have to have that negotiated up front. Next slide. So here's examples of the two different non-XML body representations. On the left, we have the base64 encoded version. And for this, we note that we've got a non-XML body element followed by a text element that has a media type or MIME type associated with it of PDF. Next, on the next line, the representation is B64, and that stands for base64 encoding. And then finally, inside that text element, there's the actual base64 encoded PDF document. We have a ... at the end because this would really probably stretch off the screen for about half a mile here for a typical document. There's a lot of encoding there, and base64 encoded documents tend to be quite large in size. The next one is the referenced file option. In this case, the first part looks pretty much the same. It's still a non-XML body with a PDF file in it, but now instead of a base64 encoded representation, we just have a reference. In this case, the file name, ud_sample.pdf, and that just points to the file, much like how an HTML document would point to a graphic. Okay, next slide. So let's move on to the XML body, or the structure bodies, that's also known. This is typically used in implementations today to store summary documents, or the body of summary documents that are exported by meaningful use certified EHRs. It includes both human readable and coded data, or human readable content and coded data. There are some document types in Consolidated CDA that use the XML body, but only require narrative. They don't require coding. But most of the ones that are, again, for use under meaningful use do require coded data. These conform to CDA implementation guides, and some examples of the clinical content are they can often contain problems, allergies, meds, procedures. Again, always with narrative, and many document types in coded form as well. Next slide. So here's an example of the narrative representation of clinical content in a structured body. In this case, we're showing up on screen the XML for an allergies and adverse reactions and alerts section. There's a text element in there that contains an HTML table with table headers for substance, overall severity, reaction, and such, and then another body row below that actually has the person's actual allergy information. And when you take this and you render it using a CDA style sheet, you would get something that looks like that rendered view at the bottom, which is a rendered table with the table headers, substance, severity, and such in bold, and then the actual content in this case, noting that the person is allergic to penicillin, and it's a moderate to severe reaction with nausea as the reaction. So all that is readily visible to a human reader. Let's go on to the next slide. So aside from narrative content that you would show to a human user, CDA documents with a structured body also can contain coded data. So this one contains an animation. So if you want to advance the first step in the animation here, we note that this first code here is the link code for platelets. Next animation. This also states the date at which this observation was made. So we're noting that this is a lab result for platelets, and it was made on March 23rd, or 2000 at 2:30 p.m. Next. We note the measured value in this case, which is 123. Next. There's an interpretation code here, noting that this is interpreted as a low result. And then last animation here. And you can tell that that's low because of this one that's being pointed to here, which is the reference range of this lab test. So for this particular test, we note that the expected range of values is between 150 and 350. The measured value of 123 is less than that low value, hence the interpretation code of L for low. If that was instead, for instance, 153, then you would expect the interpretation code to be something like N for normal. Okay, next slide. Right, so the last body type we're going to discuss is the simple XML body. So this is, again, a proposed specification. This is for CDA documents which are largely narrative in nature, but which you may optionally allow coded data. But again, no coding is required in a simple XML body. I like to think of this as an incremental improvement over the non-XML body, in that you have CDA narrative present in a single format, so you don't have to worry about CDA plus PDF. And you have the ability to add coded data where there's ROI. With a non-XML body, you just got a PDF. You don't have that option to add coded data to it. So this allows you to add value over time and also add value where it's most useful to you. Sections, in this case, have titles, and optionally, they can contain link code. So it is possible to put a minimal amount of coding on your sections to make retrieval a little bit easier. But again, they're not required. So this is currently up for ballot. The URL is listed here, but I do want to note that even though non-members to HL7 can vote in the HL7 ballots, you have to pay a fee to do that. But unfortunately for this particular one, the actual ballot sign-up period has closed. So even though I think you could still sign up to get the content, you wouldn't be able to vote in this case. But it will be freely available to anyone a few months after final publication. And the full name is listed at that bullet at the bottom there. CDA Release 2.1 or CCDA 2.1 supplemental templates for a minimally structured document, or XDoc Release 1. Okay, next slide. So here's what a simple XML body example looks like. In this case, we've got a structured body with two components in it. Each component contains a section. The top one is an allergies section with the link code for allergies present. Now that would be the same link code as the allergies section in a consolidated CDA meaningful use compliance summary document like CCD as well. So those link codes don't really change. What is different is that this one does not have any required coding in it, so there are no coded allergies. Rather, you can just quickly navigate to this allergies section using the link code if you wanted, and then you can pull it out and render the actual allergy, the human readable allergies that are present here. In this case, the person is allergic to penicillin and the reaction is hives. The second section is a problem section. In this case, we showed an example that does not include a link code. So really here it's a little bit more difficult to just search for and find the problem section if you're looking for it, because you have to deal with, for instance, issues with free text searching for problems. Maybe one case, one implementer called it the problems section with their title. Maybe another called it problem, or a problem list, for instance. It could be all uppercase. So it's a little bit more difficult to just find the problems when they're only in free text, but again, not insurmountable by any means. And in this case, the human readable portion here is just, again, it's another list, in this case noting that the person has hypertension. Okay, next slide. All right, so let's talk a little bit about rendering CDA documents. So I mentioned several times displaying CDA documents with style sheets. So basically, how this works is the CDA specification and various implementation guides often, will come with style sheets that convert CDA markup into HTML for online viewing. These style sheets can be run either directly in a browser in real time, or you can run a separate process and generate a static HTML version of the document. There are several style sheets that are available. HL7 has ones that are present in their source code repository called GForge, and they're available at the URL that are listed there below. Also, my company, Lantana Consulting Group, has produced some style sheets that are available in GitHub that take a little more modern representation, and I'll go ahead and demonstrate both those a little bit later. I also want to note that HL7 also had a CDA rendering challenge that they issued last year, and a wide variety of folks submitted style sheets or full-blown applications for rendering CDA to that challenge. We won't go into detail in this presentation just for the sake of time, but the URL is here, and I encourage folks to go and sort of look at the rendering challenge results, because there are some interesting submissions there for instance, in some cases, some JavaScript applications that will process your CDA documents and just show selected views of what you're what you might be interested in, let you choose just portions of CDA documents to render at a time. Okay, next slide. So, when you're going to use the CDA style sheets to render documents, again, you've got two options. One is to run them from a browser. This does require adding a processing instruction. It's a little snippet of XML that I'll demonstrate shortly to your CDA documents. When you do this, you can open up in a browser, and it should run the style sheet that is pointed to by that processing instruction, and then generate HTML on the fly for you. Do want to note, though, you are, in essence, referencing an external piece of software. It is an XSLT style sheet. XSLT is a programming language. Also, it's important to note that browser support for XSLT has varied over time. Some browsers from time to time have prohibited or have stopped executing XSLT style sheets. Other ones render them very well. So just kind of be aware that there might be some browser dependencies there. Which is why it might not be a bad idea to consider that second option, which is running the style sheet offline. In this case, you would use one of many command line tools that are available, such as Xalen or Saxon. You can Google those names to download the software, and this way you can convert your CDA documents to HTML in advance. And then, since you've got at that point HTML, you can just open that in a browser all the time, because that's what web browsers do. They view HTML. All right, so next slide. Let's move on to validating CDA documents and advance it one more. So validation ensures that documents are correct according to the base CDA standard and to any implementation guides. So validation will check the overall document structure as well as parts of the data, such as the codes that are used and such. Validation can check the overall XML well-formatness, as it's known, to make sure that, for instance, the correct element and attribute names have been used. It can also check that you've created a document that is valid to the rules and implementation guide. In other words, that you've used the link codes for the sections that are required, or that your document uses a US ROM header properly. It is important to note, though, that validation, there are things that validation will not check. It can't check clinical correctness. For instance, a validator typically will not throw any error if you note in the header that the patient is male, but later on in the document there's a condition of pregnancy. Also, validation will not check that the human readable content corresponds to any coded data that might be present, which is it's a written rule of CDA, but there's nothing that validation can do to check that you've actually done it correctly. Really, it will just check that human readable narrative is present in the document, but it can't really dive into and make an interpretation about how correct it is. Okay, next slide. So there are two types of validation that are typically done with CDA documents. First is what's called the XML schema or CDA schema validation. This ensures the XML is well formed. It basically goes in and checks the overall structure of the CDA document. It will not validate against implementation guide specific constraints. I'll talk about the schema that we use for that in a moment. It only checks the existence of nodes and hard document structure, like misnamed elements that are out of order, things that are required by the CDA spec and are not present in your instance. Next slide. Schematron validation is what we use to check implementation guide specific rules. Typically, there's a one-to-one correspondence between a conformance statement in an implementation guide and a schematron assertion, as it's called. What this means is that when you run schematron validation, if it comes back with an error, that error will typically point right to the conformance statement that you are failing. So it makes it really easy to trace back any errors that you get to the rules, to the written rules of an implementation guide. Schematron can validate data, so for instance that you've used the correct codes, that your counts are correct. If something was optional in the base CDA spec and your implementation guide made it required, it can ensure that that you're actually following that rule. Also, Schematron uses what's called XPath, which is the same language used in XSLT, to select or to make assertions on the CDA document. I'll give an example of that on the next page. But it's also important to note that there are some conformance statements sometimes in implementation guides that unfortunately cannot be represented using Schematron. So an example from Consolidated CDA is there's a template that defines procedures, for instance. And one of the things that it notes is that any assistants, any folks that were assisting with the procedure, shall be identified in the document. Well, as a recipient of this document, we were trying to validate that. You really have no idea what assistants were present in the operating room when that procedure was performed. So the schema can't see if that's actually correct, that you've really identified all the assistants that were present. So again, those types of real-world checks cannot be done using Schematron. Those are rules that you just have to follow as a document author. Next slide. So here's an example conformance statement that I've got up on screen here. It says shall contain exactly one class code attribute valued with the string OBS. So what this means is that in your instance, wherever this one occurs, probably in an observation, you must have an attribute, an XML attribute on that observation that is called class code. It is illegal to not have that present because that minimum cardinality is 1, not 0. And also its value must be the literal string OBS. So if you were to make that lowercase OBS or OBSX or something like that, that would actually fail. So let's advance the animation on this slide. So this constraint expresses the cardinality, again, that 1.1, it's saying that's required and only one can be present, and the value of an attribute. Next step. And here is an example schematron assertion that could check this rule. In this case, we're noting that you must have an observation present with a class code attribute, where the value of that is, again, that literal string OBS in all uppercase, and the count in this case of this occurrence is 1. Again, if you tried to run that check and your count came back at 0, you would fail this, and that could fail for a variety of reasons. Again, maybe your class code attribute wasn't present at all, or maybe it was valued with a different string, in which case that count would be something, again, would come back as 0. Okay, next slide. Right, so for validating CDA documents, there are quite a few tools that are available. HL7 provides the CDA XML schema, as well as CCDA schematron schemas. In fact, nearly all implementation guides come with schematron schemas to test their rules. And you can find those in HL7's GForge repository, same place you would find the HL7 provided CDA Style Sheets. There are also online validation tools that are available. O1C has a CCDA scorecard up that tests things like meaningful use compliance. There's also an older edge testing tool that was used during EHR certification. And our company, Lantana, also provides an online CDA validator that tests many different implementation guides beyond just CCDA. Next slide. All right, so at this point, I'm going to request that Jessica, that you make me presenter. I'm going to walk through a few live demonstrations here.
You should have control now, Rick.
All right. Here we go. So I'm going to show my screen up now. All right, so I'm going to start by showing the CCDA or Consolidated CDA implementation guide. So I mentioned implementation guides before. This is basically what they look like. In this case, this is the IG for Consolidated CDA Release 2.1. And how you would typically use this is you would think about the use case that you're trying to satisfy. For instance, let's assume you're trying to put out a document that contains a vital signs section. So what you could do is you could just search for this document for vital signs, for instance, and find in the table of contents some of the templates for creating a vital signs section. In this case, we're going to use the vital signs section with entries required, since I want to show not only how narrative works, but also coded data. So this is present on page 412. So I'm going to jump to page 412 in this case. And here is the section for the vital signs entries required section. And we can note at the very top, there's this little table here that says what this is contained in. So you see vital signs appear in consultation notes, continuity of care document, a transfer summary, and a referral note. So if, that's useful, again, if you want to find out what document types typically contain vital signs. And you can also see that this one contains what's called a vital signs organizer. I'll get to that in a second when I talk about the coded data for a vital sign. One of the most useful parts in this implementation guide is this table here that actually lays out all the various elements and attributes in CDA XML and what their requirements are. So again, I discussed those cardinality indicators. They're present under this column. So we can see that this vital signs section, for instance, must contain a code, because it's a minimum code of 0 here. And that code needs to have an attribute called code that is valued with this string from LOINC. So with that, for instance, you can quickly navigate through a document and find your vital signs section. If we scroll down a little bit further here, again, we see that the title and text and all that is required as well. And then we get down to this point where we've got this organizer. This is the beginning of the coded data. And I can click on this vital signs organizer. And this will take me to the, oops, screen's kind of jumping around there, the definition for an organizer. Organizers in CDA are used to group related observations. In this case, this would be, for instance, an organizer containing all the vital signs that were taken during an encounter, such as the person's height, weight, maybe their BMI, their blood pressure. Organizers in this case, often have a code and a date associated with them, such as this effective time here. And then inside it, they'll have a series of components with the actual discrete observations. In this case, we've got a vital sign observation. If I were to click on this, and vital signs observations would again contain things like their height, their weight, their temperature, their blood pressure. And the rules for this are basically that you would have an observation that's going to contain a code saying what it is that you're measuring, the date that the measurement was taken, and then a value with the actual measured result. And optionally, they can have things like interpretation codes and such. So in CDA XML, it's going to look somewhat like this. So I've got this CDA or CCD document open, and I'm going to do a search for that LOINC code. And apologies, some of these dialog boxes are a bit small, but I'm going to search for that vital signs LOINC code, and boom, it takes me right to the vital signs section. So I can quickly grab this and extract that whole section if I wanted to. There's the text representation of the vital signs that is present here, which has, again, if you bring this, render this in a browser, you'll see the person's height and weight present at the various dates that these vital signs were taken. So that's all present in the narrative. When I move down to the coded data, we see again that vital signs organizer. In this case, we note that this is the SNOMED code for vital signs. We note the date when these vital signs were measured. And then we can go down and look at the actual discrete observations, such as in this case, we measure the person's body height. So there's the link code and the display name of it. And we can see that the value in this case is 177 centimeters. And again, this is going to match what you see in the human readable narrative as well. All right. So enough on the structured body. Let me move on to the other implementation guide that I discussed here, which is the minimally structured documents, or simple body as we called it, the XDoc spec. So in this case, we have an implementation guide that, actually I wanted to mention Consolidated CDA. This implementation guide has hundreds of pages, not over 900 pages in this case. The XDoc implementation guide has 9. So this is a much simpler implementation guide. Really, all we do here is we note that you must use the US ROM header. So we require that you have a template in there for the US ROM header present. And then we note that you need to have a structured body. But otherwise, other than that, the rules are basically loose. You can have 1 or more components, each containing a section, and that section can contain anything that you want at that point. So you can actually go down here and look at the actual conformance statements and see that you need to have a structured body, shall contain 1 or more components, that shall contain exactly 1 section. So as you can see, that's quite simple. If I go back to the XML for this and look at what a simple XML document looks like, you'll find that at the very top, this information looks very similar to the CCDA version, or that CCD summary document. That's because, again, it uses that same US ROM header. It's really when you get down to the body here, beyond all that metadata, that you find things look a little bit different. The sections, in this case, are often very short. They'll just contain either a link code, a title, and some text, or in many cases, they don't even need to have that link code at all. But it does have the advantage that you can optionally, for instance, as we're showing in this vital signs section, if you wish to add coded data, you can. There's nothing that prohibits you from doing it. So if, for instance, for your use case, you started off with narrative-only documents, but one of your recipients said, hey, it would be really valuable if you could code the vital signs for us, or code the lab results up for us. We don't really care about the rest. It is perfectly legal using the simple XML document to add just that coded data that they ask for, the best bang for the buck in this case. So that's the advantage there of using that simple XML document, is you can, you're not required to put in the coding, but you can use it where it's valuable. So let's go back to this CCD document. I'm going to talk a little bit about rendering. So I mentioned briefly that you can render using style sheets, and also that if you're going to do that directly in a browser, you need to have a processing instruction present. So this is what that processing instruction looks like. It always appears at the top of the document above the actual root element for CDA, and it just lists the file name or URI of the style sheet that you're going to invoke. And when you do that, when you launch this in a browser, and I've just got this particular tool is called Oxygen XML Editor, by the way, and supports viewing XML documents pretty easily. So anyway, I'm launching this now in the Firefox browser, and I can go in here and see how this document was rendered. In this case, we note the patient is Eve Betterhalf. We can scroll down and look at all that header information that's present. Then we get down to the body, we can note section by section the content. So if I were to click here and go down to vital signs, I can see the rendering of that vital signs section. It's important to note, though, that CDA markup is generic. There's nothing in there, if you remember from when we looked at it, nothing in there that says what colors are to be used or what alignment is to be used. All that's done, in this case, using the style sheet. So what that means is if, say, for instance, you don't happen to like the look of the HL7 provided style sheets, you can provide your own. And in this case, I'm going to change this to use the Lantana style sheet that's available on GitHub and render this one instead. And sizing on this one is a little bit different. And in this case, we've got that table of contents always present on the left, so this makes navigation a little bit easier and takes better advantage of the widescreen real estate. We have all the header information here still up at the front. You can basically go down here and scroll down and jump directly to the vital signs section, for instance. And you see also that the rendering of the tables is slightly less of an eyesore approach. With you don't have those bright yellows and blues and such, so it's a little bit easier to read in many cases. And again, all these style sheets, even the HL7 one and the Lantana one, are available. They're open source, so you can even modify them to meet your own color schemes, have your own logos and such available as well. So moving on, the last thing I wanted to cover today in the demonstration was validation. So I mentioned schema and schematron validation, and I want to show you how they work together. In this case, I've got a CCD document up that has a couple errors in it. So the first thing I'm going to do is I'm going to validate this document against the CDA XML schema. So I'm going to run validation. I've already got it associated with the schema on my file. And it comes back, and again, apologies, doesn't make these very big and readable here. Actually, let me see if I can increase that slightly. No, it's not going to let me do that. Okay, but if I were to double click on this error, basically what it says is that title is appearing in a place where it's not expected. One thing that the CDA schemas do is they enforce the order of elements and let you check them. So if I were to bring up the CDA XML schema in this XML editor here, I can take a look at it and see, for instance, that title must, if it's optional, first of all, but if it appears, it must appear before effective time. When I go back to this document with the errors, I'm seeing in this case that I've got title appearing after the effective time. All right, so to correct this, I would actually copy and paste it, or cut and paste this, move it before, and then I could save this document. And now when I validate, it says the document is valid, so that goes away. However, that's not quite the end of the story here. For this particular document type, which is the continuity of care document, or CCD as it's called, or actually continuity, let's search for this. So this is on page 115. Okay, so one of the rules at the very top of the continuity of care document is that it must have a code present, and this code must be this value from LINQ. Right? So there's actually a corresponding conformance statement with this right here. Now, what this means is when I generate a schematron schema for this implementation guide, it should be able to check that rule. So I'm going to go ahead and validate with, again, one of the things I like about this tool is it will do schematron validation as well as schema. I can note that I'm only interested in errors at this point, not warnings. And then when I run this validation, this is actually going to compile that XSLT, or compile that schema to a XSLT file that'll generate a report. In this case, it's reporting that this conformance statement is failing. That one that requires that LINQ code. Okay, and if I look here and I find where the LINQ code is present, if you notice, I've got an X at the end of it instead of the required value that was present in the implementation guide of this. So when I remove that X, save this document, and run validation again, that error should go away. And there we go. So now it's validating once more. And do want to note schematron validation takes a couple seconds longer than schema validation. In this case, it says validation successful. So now I know that I've got this successfully created. Last thing I want to show is just a quick demo of the CCDA scorecard on the ONC site. This one is basically, again, they put it out there to sort of improve the quality of documents that are exchanged under meaningful use. And it has some interesting features. It can do just like the schemas that I showed here and check errors. So if I were to use one of their samples with errors and click try me, it'll come back with a scorecard result. In this case, all the errors are listed in black here. So I can click on one of these, for instance, and it'll list all the issues that it found with the patient in this case. I can likewise go back up at the top and say, okay, well, what's wrong with my immunizations? And it'll list, again, the conformance statements that I'm failing in this case. But one of the neat things about this is it goes a little bit further. Not only does it check errors, but it also notes things that are done well, giving you an A+, and things that are maybe not so good, such as the vital signs in this case. They qualify as a B-, and things that are maybe C's or D's. So technically, these are legal to the spec, but they're not done very well. So for instance, you could click on here under the problems, and you should note that it says that effective date elements should have the correct time zone offsets. So in this case, they listed a date, but they didn't put a time zone in it. So what do the times in there really mean? So those are the kind of things that this will catch. Also, you can close the results. You can try one of their high scoring examples. In this case, see that you've actually followed all their rules and improved your documents over time and got something in this case is scoring an A+, well, B+ on the meds. So that's about it. I think, Jessica, I'm going to hand this back to you now, and we can wrap up with the Q&A.
Thank you so much, Rick, for such an informative presentation. And we're going to do one quick polling question, give you time to take a short break, and then we'll go to Q&A. So let's go to our second polling question, and let's go ahead and launch it for the so for this polling question, we're just trying to get a little bit of information about our audience. So which type of CDA body do you feel is most useful for your use case? First option is non-XML body, in other words, no coding, PDF, MS Word, etc. Second option is XML body, and the third option is simple XML body. So let's go ahead. We'll give this a few minutes to see what we learned from our audience. And Rick, if you don't mind, when we see the results, I'd love to hear your take on the responses.
Absolutely.
So let's close this in maybe 3 seconds and share the results. Okay, so we're sharing the results, and it looks like the first option got the most response, so that's a non-XML body, followed by the simple XML body with 30%, and then the close third option with 29% of the vote is the XML body. Is that what you anticipated?
Well, it's very interesting. I think it sort of justifies the work we've been doing for attachments and such, and that we recognize that there are a lot of document types out there, a lot of administrative documents that aren't going to be fully coded. I think this is maybe a bit of a, could be an interesting observation that the approach taken, under meaningful use doesn't actually meet a lot of people's use cases, at least when you're talking about attachments and reimbursement and such, that extensive amount of coding doesn't seem to necessarily justify it. But all of these are actually all pretty close. I mean, it's not quite a third each, but we do see things split fairly well here. I'm happy to see the simple XML body beating out the XML by 1 point. So anyway, thank you all for participating in this.
Thank you. And so now we'll move on to the Q&A portion of the webinar. And as I mentioned earlier, you still have time to submit your questions, but we have received a few questions. So the first question, Rick, during your presentation, when you were talking about the base standard, you used the term legal. I believe it was slide 24, but you used it a few times. And one of the questions was if you could elaborate on what you mean by legal in the context of the base standard.
Yeah, well, there's potentially two there. I have to remember exactly what slide I'm talking about. But there is a field in the header called the legal authenticator, and that's legal from the perspective of the person who has the legal authority to attest to the clinical content. But I'm guessing the use in this case is probably more along the lines of legal in terms of conforming correctly to the specification. I guess I would use that term as sort of a software developer or implementer to state, that a legal constraint on the base CDA standard means one that doesn't break the rules of CDA. So I hope that answers the question. If you write a conformance statement that actually contradicts the base CDA standard, that would be illegal because that would actually be generate errors.
Thank you, Rick. So the next question is, what are the benefits of using the CCDA to carry a PDF other than maybe being a stepping stone toward using structured data?
Well, the advantage of is maybe your use case doesn't need any structured coding at all. You may never use that as a stepping stone for coded data for things like administrative documents that simply have no need for coded data for reimbursement. So I don't see this as a stepping stone. I see this for many implementations as an endpoint. It satisfies the need. It's all you need at this point. If you're, again, a receiving system can't process the codes anyway, why add them?
Thank you, Rick. The third question is regarding encryption. So why aren't these standards encrypting messages?
How I would respond to that is the standard itself is a data format standard. It describes what the XML needs to look like. CDA does not say anything about transport, encryption, security that exists in the ecosystem outside. Now, when you exchange these, you absolutely should be sending these over encrypted channels. You should have systems that encrypt the content at rest. But again, this is just like any other XML file. It's a payload. It can work with any standard. You can send it over HTTPS. You can send it over a variety of other system, transport mechanisms and such. So the encryption just happens at a different layer, so to speak.
Great. We've got a couple more questions for you, Rick. The next question is, which type of CDA body should be the accepted standard for interoperability and automated data exchange? Seems like non-XML is the de facto easy route. Will the industry achieve seamless exchange of clinical data via attachments?
That's
to be honest, a lot of questions.
Yeah. I think the answer is all of them. Again, as I tried to, the point I tried to make during the presentation was it really depends on the use case. If you've got a meaningful use certified EHR, by all means, export those the ones with the structured body that have all that coded information. It's already done for you. You might, there's no reason not to use it. If, however, again, you've got administrative documents or scanned paper documents that you need to scan, use the non-XML body. And if instead you've got a system that maybe you've got access to the source code for and you can export that simple XML body, but you don't have a budget for doing terminology, then do that one. They're all CDA documents. It really doesn't matter which body type you use. In any case, they are CDA documents. So it'll work, anyway, and they all share that same header metadata.
Thank you, Rick. And I think we are out of time today. Thank you so much for spending the time with us and going through all of this detailed information. We really appreciate it. I also want to thank our audience. I also want to thank the audience for taking time out of your busy schedules to join us. On the next slide is a little bit of information about our next webinars. And then as a reminder, the links to the webinar slides and the recording will be available for downloading starting tomorrow. They're not on there now. We will also email you the information in the next day or so. So if you do nothing, you'll still receive the slides and the recording. I'd like to also note that we've included slides at the end of this presentation. So starting on slide 58. That cover the material that Rick presented during the live demonstration. So you'll have some of that background information and the links that he presented during the live demo. And with that, I'd like to say thank you to you all again. Keep in touch with us and enjoy the rest of your day.
Thank you all.